Good morning, this is Dr. Turner for Fundamental Math. Today we're going to be looking at 10.5, the last of the Fundamental B course, which is going to be looking at Pythagorean Theorem. Many of you have seen this before, or at least familiar with the name. It is a little bit tangent from what we've been covering so far in Unit 10, but important to know as you're going into Integrated Math 1. So let's go ahead and get started here. Pythagorean Theorem is derived a number of ways. And if you're in a geometry class or an integrated math 2, you talk about ways that you can do that, of how you can figure out how to solve for the Pythagorean theorem. But for us, we just want to be familiar with what it is and when to use it. Pythagorean theorem is used when you are looking at a right triangle specifically, and you want to be able to solve for a missing side. So long as you know two of the sides of the triangle, then you can use Pythagorean theorem to be able to solve for the missing side. So when you're doing this, the formula is a squared plus b squared equals c squared, where you have your two legs. These are the shorter sides of the triangle. And then you have the hypotenuse, which is c. Now the hypotenuse will always be the longest side of your triangle, and it's always opposite your right angle. In terms of the other two legs, it doesn't matter if this is A and B or vice versa, if A was the bottom and B was the side. As long as you have the hypotenuse in the correct spot, A and B can be swapped interchangeably, okay? So using this formula, if you know two sides, you can solve for the third. Whether you have two legs or whether you have a leg and a hypotenuse, as long as you know two, you can solve for the third. Now, just like we've been mentioning in Unit 10, of course, there are going to be cases where you end up with answers that are decimals or simplified radicals. Those are skills that we're going to cover more in Integrated Math 1. For now, I'm giving you all examples where your answers are integers, so just be aware of that. And when you're looking at right triangle problems that involve integers, we have something that's known as Pythagorean triples. And essentially what Pythagorean triples are, they are side lengths that are common on a right triangle, but more specifically, they are side lengths that are integer sets. Most common of which are 3, 4, and 5, and then also 5, 12, and 13. So as you do more and more and more right triangle problems, you start noticing a pattern specifically between these two sets where if you know two of these numbers or you see and recognize two of these numbers, you can write the missing side without having to be, having to solve it. That is all to say, of course, you can always use the theorem, but if you recognize the triples, then it saves you a little bit of time on a standardized test. Okay? So this is what this looks like. And I could draw you a diagram, or I could just simply write it out in words. But let's say I have a right triangle. And we'll start out with one of these that we put down here for Pythagorean triples. Let's say I tell you that I have one leg that is 3 and one leg is 4, and I want to know what the hypotenuse is. Okay, so that's my unknown. So you would be plugging these values into the Pythagorean theorem. I have here 3 squared plus 4 squared, which is equal to x squared or c squared. That's what I'm trying to solve for. 3 squared is 9, 4 squared is 16, and I'm going to solve for x squared. Now I mentioned here at the beginning that 3 and 4 can be switched. So remember your commutative property. If I had put 4 first instead of 3, 16 plus 9 is the same as 9 plus 16. So both of those are going to be equal to 25. And then when I get to this step, this is x squared. So think back to what we've been doing in 10.2, 3, and 4. You're doing the opposite operation. The opposite of squared is square root. So to get x by itself, I would be taking the square root on both sides. Now, technically, the square root of 25 is both positive and negative 5. But because we're talking about length, we can't have a negative length. So we're sort of ignoring the negative value. My answer here would be just 5. Now, looking at this problem, as I mentioned with Pythagorean triples, I could have told you that missing side was 5 because when I see 3 and 4, I know the number that completes the set is 5, right? So if you know those Pythagorean triples, then it's a shortcut. If not, you do out the arithmetic, and you still end up with the same answer. Okay. Let's do another one. Let's say I have, again, another right triangle. It doesn't have to be oriented that way. It can be oriented any way, just as long as you are able to recognize which side is your hypotenuse. So let's say I have a triangle like so. I'm going to, let's say, solve for the hypotenuse again. Here's 5, here's 12. Following, again, one of these triple examples. But if I didn't recognize that, I'm using the formula. 5 squared plus 12 squared is equal to what I'm trying to solve for, x squared. 5 squared is 25. 12 squared is 144. And then that's equal to x squared. 25 plus 144 is 169. And then I would take the square root on both sides, ignoring the negative because we're talking about length. So that missing side is x equals 13. Okay. Now, when you first start doing the Pythagorean theorem, you fall into a sort of a pattern of seeing two numbers, squaring them, adding them, taking the square root. But that is not always the case. That is true if you are given two legs and you're asked to solve for the hypotenuse. But if you're given the hypotenuse and one leg, the procedure is a little bit different. So, for instance, let's say I have, and these aren't drawn to scale, of course, as always. Remember, with any diagram, you're going by the given information, not by what it looks like. But let's say we have another right triangle here, and I tell you the hypotenuse is 10, and one of the legs is 6, and I want to solve for the second leg. So if you recognize Pythagorean triples, you can solve for that without having to do the arithmetic. Otherwise, you're using the formula. This is x squared plus 6 squared equals 10 squared. Recognize that in numbers 1 and 2, we had two legs and we were solving for the hypotenuse. The hypotenuse is always going to be by itself on the right-hand side of the equation, right? It has to be by itself. That's the formula. So whether it's your variable or whether it's a given side, the hypotenuse is by itself. From here, we do the arithmetic. 6 squared is 36. 10 squared is 100. If I subtract 36 on both sides, I get 64. And then I would take the square root of 64, ignoring the negative, to get the missing side, which is 8. 3, 4, 5, and 5, 12, 13 are the most common Pythagorean triples that you'll see on a standardized test. Also, any multiples of these numbers are also Pythagorean triples. So for instance, 3, 4, 5, like we just saw, if I multiply those by 2, 6, 8, 10 is also a Pythagorean triple, as is 9, 12, 15, as is 12, 16, and 20, etc. 30, 40, 50. So any multiple of those number sets is also a Pythagorean triple. Same thing with 5, 12, and 13. If I multiply it by 2, 10, 24, 26, or if I multiply it by 3, 15, 36, 39, etc. Those are all Pythagorean triples. Now, I will say that maybe 70% of the problems that you're going to see, if you are given integer values, are going to involve these 6 right here. These are the most common Pythagorean triples that come up. They account for, like I said, about 70% of the questions you'll see on a standardized test. So if you're familiar with those, it helps. But once you've seen 3, 4, and 5 100 times, it starts having to sink it, starts sinking in. You don't have to do the arithmetic. It doesn't hurt to do the arithmetic, but it's meant to save you a little time on a test. Okay. Let's do one more. Let's say I have, again, not drawn to scale, another right triangle here. I want to solve for the missing side. My hypotenuse is 25, and my other leg is 24. So, filling in the formula, x squared plus 24 squared equals 25 squared. And you can use a calculator if you need to. The calculator is enabled on the assignment. 24 squared is 576. 25 squared is 625. Subtract those values, you get x squared equals 49. And then take the square root, ignoring the negative value, you get x equals 7. That's it for 10.5. If you guys have questions, please reach out during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.